In this video, I'm going to be going over Module 11.2, Explain To, which is simplifying radical expressions using properties of exponents. So when you are working with radical expressions involving nth roots, you can rewrite the expression using rational exponents and then simplify using the properties of exponents. So on example 2, we have simplified the expression by writing it in rational exponents and then using the properties of rational exponents. Assume that all variables are positive. Exponents in simplified form should all be positive. So if we look at example A, we want to first rewrite the expression using rational exponents. And so I see this is in radical form and this is in radical form. And so if I rewrite that, remember the index becomes the denominator, and I get 2y to the power of 1/3. And then for this one here, I get, again, the index is the denominator, so I get 4x squared, y squared, all to the power of 1/3. And if you notice, this exponent and this exponent are the same, and so I can group these up, and I can take that exponent and put it on the outside. And when I do that, I get things inside that simplify, like 2 times 4 is 8, y times y squared is y cubed, and that x squared stays right there. So here I have a simplified version, or a little bit simpler, and I see this exponent on the outside which can be distributed to each one of these. And so 8 to the power of 1/3 is the cube root of 8, which is 2. 2 times 1/3 is 2/3, and 3 times 1/3 is 1. And then the last thing I see is that I have an x here, which has an exponent of 1, and an x here, which has an exponent of 2/3. And so I can go ahead and add those exponents. So I'm going to get 1 plus 2/3, and I need to get common denominators. So I multiply top and bottom by 3, and I get 3/3 plus 2/3, which is 5/3, which is how we get x to the power of 5/3 here. The 2 just came down and the y just came down. So the first thing we did was we wrote it using rational exponents, then we used our properties, and the last thing is we should make sure that all of our exponents are positive, which in our solution here they are. So let's turn the page and look at example B. So again, we're going to do the same thing we did in the last one, where we rewrite. This here is a square root, so I'm going to get 64y to the power of 1/2. And then my denominator, this is a 3, so I'm going to get 64y to the power of 1/3, which is actually the first step written right here. So now if you notice, you have the same base and the same base. So with our exponents here, if you remember the quotient property of powers, you can subtract those exponents. So 1/2 minus 1/3, and I'm going to show that work over here. I need to make sure I get common denominator, and between 2 and 3 needs to be multiplied here, and 2 needs to be multiplied here so that our common denominator is 6. So 3/6 minus 2/6 is 1/6. And now I have 64y all to the power of 1/6. And so with an exponent on the outside like that, if you remember, we can distribute it to both of them. So 64 to the power of 1/6 times y to the power of 1/6. Now 64 to the power of 1/6 right here is the same thing as the 6th root of 64, which if we break down 64, we would have 2 and 32 and 2 and 16 and 2 and 8, and 8 is 2 times 2 times 2. So when you're talking about the 6th root, you're talking about 2 that repeats 6 times. So the 6th root of 64 is 2. And so I have 2y to the 1/6. So a quick little recap is that you write the rational exponents. So we rewrote these radicals as rational exponents. And then we used our different properties in order to simplify. And the last thing is that we need to check this and make sure that they're all positive exponents, which they are. So now you're going to go ahead and do what we did in A and B, and you're going to go ahead and do it for your turn 5 and 6. Good luck.